All right, everybody hear me okay? All right, so let's do one thing really quick too, because I know you're excited and you really want lunch. I want everybody just to scream as loud as I can. 1, 2, 3. All right, good job. Yeah. All right, now it's my turn. Okay. All right, that's just to get it out, okay? Now we can sit just for a few minutes. I'm not gonna try and get up here and bore you to death or anything like that. I want you to see that you can have fun, and especially in the STEAM fields. And that's kind of my purpose, my goal is to get there. So as mentioned, my name is Dr. Peterson. I came from Fresno State. I teach in the geomatics engineering department. And a lot of the stuff that you see downstairs, a lot of the stuff that you get to see here, there's a lot of the things that I get to teach with, and that they help you guys learn from. So as everybody leaves today, hopefully you'll learn a little bit more about kind of what I did and why I got so excited to get into the field and into my profession, and then hopefully that'll lead you guys somewhere else as well. So first, just let me put it this way. Let me I guess have a raise of hands of those who knows what they want to do when they grow up. Bunch of liars. You guys are a bunch of liars. You don't know what you want to do. What? Okay. So let me tell you something. So this is how it works. So when I was a kid, when I was your age, I wanted to be a doctor. I wanted to be a medical doctor. I wanted to be able to go and operate on people. I got to see a bunch of surgeries in person, and it was the coolest darn thing, and that's what I wanted to do. So I went to school. I went to school then, and I became a biology major. And that's what I graduated in, was in biology. So I thought this is going to be awesome. But the whole time I was going to school, I was working for what we call a land surveyor, or a geomatics engineer. And this geomatics engineer, he brought me on just to give me a summertime job, to let me work throughout school, and let me do a lot of fun things. And so what happened was, I started to see and started to understand that I had this great affinity towards doing something different, towards doing something other than what I'd always taught myself and what I'd always thought this is what I wanted to do. So when I was getting close to graduation, I decided, you know what, I'm going to change direction. I'm going to change my mind. I'm going to go into engineering. I'm going to go do something totally different than what I thought I was. So I did that. And it's been the greatest choice of my life. Why? Because I absolutely love what I do. I worked in industry for several years, for probably about 11 years. And then I decided, all right, I want to do even more. So then I went back to school to even do more school. So hopefully you guys love school. Yes, sir. You want to live? Okay, all right, well, good for you on that one. Okay. All right, so what the idea behind telling you that kind of story is how I kind of fell into the engineering side, is the idea that I hope every single one of you kids that are here, hopefully you guys are here because you have some sort of attraction and affinity towards what you're seeing today. Right? You want to code, you want to do something in engineering, something in science, something in technology, which is dang awesome. And I hope to see you guys out there because you guys are the future. But I want to make sure you guys understand, though, is that don't let what you think today dictate what you're going to be doing tomorrow. It took me several years to figure out that I didn't really want to go into medicine. I really wanted to go into engineering. I fought with myself, fought, because I thought, you know what, I'll let other people down. I'll let my parents down because that's what I told them I was going to do. You know, ever since in high school, I told them I was going to be a doctor, and when I go back to reunions, I want to make sure I go back, hey, I'm a doctor now. So I ended up being a different doctor, but not the kind of one I intended to be. But the idea for you guys, and I hope you walk away from, is understanding that it's awesome to have a dream now, but it's also awesome to continue to dream. And when you find things to do, and you find things that interest you, I hope you follow them. And I hope you're not pushed only in one direction. You guys are still so young and still just ready to absorb all sorts of knowledge and all sorts of everything. It's from that point that I hope that you'll learn from it and then begin to grow into what it is you want to do. Remember, you have the rest of your life to work. You have the rest of your life to do something. Hopefully then, whatever you get into, then is going to be the thing that you love most. So don't let anything else, just because you feel like that's it. I've started school. I have nothing else I can do. Don't let that stop you. I've got a lot of students that come up to me, and they're already a couple years into their education, and they don't realize that, well, that's not really what I want. They've got it. You have to be willing to change because you've got a whole rest of your life to enjoy. You might as well enjoy what you do. So let me kind of get on to a few little things here. So I've got a few little videos to share. Some of these things you probably have already seen on TV as commercials. But I want you to kind of get the idea of how exciting engineering is, how exciting science, technology, everything, math, everything associated with it. How exciting things can really be, and then I'll continue to talk about a few little things.
Today, right now, you have more power at your fingertips than entire generations that came before you. Think about that. That's what technology really is. It's possibility, it's adaptability, it's capability. But in the end, it's only a tool. What's a hammer without a person who swings it? It's not about what technology can do, it's about what you can do with it. You're the voice, and it's the microphone. When you're the artist, it's the paintbrush. We are living in the future we always dreamed of. We have mixed reality that changes how we see the world, and AI empowering us to change the world we see. You have more power at your fingertips than entire generations that came before you. So here's the question: what will you do with it?
So I hope that you guys understand that part. There is a lot of technology out there, but it's you guys the ones that drive it. You guys are the future of how things are going to change. And I am just so stoked and excited to know what is actually going to come out of it and what you guys are going to come up with. Okay, so here it is. Science, technology, engineering, arts, and math. Hopefully that's what you're looking into. And if not, I hope you enjoy what it is you do. I hope that you do get excited about it today. I hope you get excited about what I teach and what I do, because I absolutely love it. And the future is bright for you guys, for everything what I teach and everything that we're doing. So anyway, so there's just some background on me again, but it took me a while. I went through going into biology, then into surveying, and then to a master's and PhD, but it was so worth it. Why? Because now I get to come here, I get to do things like this and talk to you guys and hopefully inspire you guys to want to do things like this. Do things like this. I know you guys love doing things with your hands, designing something, building something. I mean, something as simple as that little contraption right there, Lego Technic, to be able to go in and build something. That's the basics. My kids love it. And I hope you guys enjoy it as well as we do little things like that. So a lot of those little things, like in my life, in my family, I've got this blended family. I've got kids, I've got my son that is so unbelievably smart, artistic as well, more like his mother. Me, I can't draw anything nice and freehand. I have to have a ruler. That's just my way of thinking and the way I do it. All right, so what I'd like to do is I'm going to do a little experiment with you guys. Okay, a little biology experiment. So don't put your glasses on just yet. So I got a question for you. You guys ever hear of 1 dimension, 2 dimensions, 3 dimensions, the 4th dimension, all those kind of things, right? So in what kind of world do we live? 2D? So I want you to raise your hand. Do we live in a 2-dimensional world? Do we live in a 1-dimensional world? Do we live in 4 dimensions? So that's to a degree. How about 3? That's more like what we are, right? So the coolest thing, though, about all this science and technology is that we're always mimicking what our bodies are already doing. You wonder where some of these things come from. Those glasses that you're holding, you wonder where that comes from. So what I want you guys to do is I want you to pick one spot up here on the wall. So see this little wireless device over there, the router over there? I want you guys to all look at it. Now what I want you to do is I want you to close one eye. Everybody look at it. Close one eye and look at it. Okay? Now, but not with the glasses. Not the glasses yet. So as you look at it, now what I want you to do is open the other eye and close the one that you just had open. Now do it back and forth really quick. What's happening to the object? Is it moving? No, it's not moving. Look, it hasn't even moved right there. But it's a perception, isn't it? So when you only have one eye, did you know you're only seeing in 2 dimensions? So you can't tell depth anymore. You lose it. But maybe it's that eye's broken. So if you use the other eye, maybe that's the one that works in 3D, right? Does it work that way? So you need both, don't you? Now all of a sudden when you have both open, you can see 3D. Well, it all comes from this principle we call photogrammetry. Photogrammetry allows us, we have 2 perspectives, 2 eyes right here that are just far enough apart that when it comes together and looks at an object, we can now see 3D. I mean, it's just amazing. And so from that, now you have games that are in 3D. Now you have virtual reality that's 3D. You have all this kind of stuff that is 3D. Yes, sir? You miss it, don't you? Yeah, because it's all in 2 dimensions, right? Okay, so what I'm going to do then is what we're going to try is I've got a few little things that we're going to try with the glasses and see if you guys can see in 3D. So this is kind of stuff that you guys can do at home. You can go on the internet, you can go onto YouTube, and you can search little things like this. So this is what we call anaglyphs. What it is. So before we do this, what I want you to, before you put the glasses on, look up at the image right now. Can you see things very clearly yet? No. Why? So what you do see is you see 2 images overlaid on one another, but they're offset just a little bit. So with the glasses, when you put these glasses on, what they do is they filter one image out from the other. So one filters one and allows the one image to go through, the other filters the other and allows the one to come on through. So now what I want you to do is I want you to go ahead and put your glasses on. I want you to see if you can see that okay. And if you can't see it, feel free to come on up here, come up closer. Give your eyes a chance to adjust. It's hard. So it feel like you're falling down the building? Yes. Everybody out there, can you guys see it? If you can't see it, come on up. Okay, now we're going to try this. Can you guys see it coming out at you? So again, with these glasses, you guys can go home and do this on your own computer and check it out. It's a little harder to see up here this way, but it's the exact same thing. I got a few of these just to go through and show you real quick. Okay. So here's a question though. How much cooler is it to see in 3D than it is in 2 dimensions? Isn't it way better? It is way better, isn't it? So here's a little story for you really quick. So a couple years ago, I was playing volleyball, and I landed and I twisted my knee really bad. And I tore my ACL, just completely blew it out. So I learned something that day though. Not that day, but I learned later when I had to have surgery. So my surgeon, so he was an older surgeon. And so when he went in to fix my ACL, you know what he did? He cut holes, not holes, but lines from about the top of both knees all the way down to about right on the top of my shin. So I've got these long scars now that are this long. So he went into one knee and he grafted out part of the tendon so he could put it into the other knee. So he could fix the bad thing. But now I asked him, I said, well, I thought you could do stuff like arthroscopic, where it's all done where they just stick little cameras inside of you or whatever. He's like, oh no, I don't do it that way. I don't trust that yet. I cut it all the way open so I could see everything inside of there. He cuts it so he can make sure he sees everything perfectly, and then he sews you all back out. So then, fast forward a couple years after that, I hurt my knee again, and I had to have surgery. This time, the doctor went in with cameras. And instead of having these huge incisions, I have incisions that I can't even find anymore. The scars are completely gone. So which would you rather have? Probably the camera, right? But then the question is, well, how does that work? You guys have your phones, right? You can take pictures all around. Did you know when you take a picture like that, that's all in 2 dimensions, right? Totally 2D. So how then does a camera inside of you help them figure out how far to go and how not far to go? They're in there cutting something and all of a sudden, whoop, didn't mean to cut that one. He doesn't need it, it's okay. No, what it does is they have 2 tiny little cameras right next to another, which allows them to see 3D for the perspective to be able to see depth and see all that kind of stuff. So you can see that the technology and where they've come from, instead of opening you all the way up to see so your eyes can see, they can do things through cameras, which in my mind just completely amazes me that we can do things like that.
Historical sites are disappearing, but artificial intelligence can help us bring history back to life.
If you don't know where you come from, you don't know where you go. We use Microsoft AI to help us reproduce historical places.
I need to make it possible because it's so important to do it.
To recreate the site, we had to stitch hundreds of pictures, one by one.
With Microsoft Artificial Intelligence,
we are able to stitch hundreds of thousands of pictures in one night. Before, it was just a representation of the site. With this technology, you can go in, you can experience it.
Let's go in another place. I'm ready for the next one.
Artificial intelligence lets us experience our past. It helps us create our future.
I love little commercials like that, so you guys see. So everything that you're just showing and talking about is what I teach at President's Day. That's all photogrammetry. When a drone goes up and takes a bunch of pictures, we kind of stitch them all together. We put it together. That's what technology can do for us today. And it saves us so much time to do things which we couldn't do in the past. And when I see this, it makes me so excited to see what you guys are going to be able to do in the future. To even go beyond what we can do with drones today. So to get to that point, you guys should get into a lot of understanding of what it takes. It's not just taking a fancy picture. It's understanding what's at the heart of it. It's code. It's absolutely code inside of it. And as you understand the code, then you understand then what to do and how to manipulate it, how to fix it, how to make it work to benefit you and whatever it is you are working with. And so what we're going to do then, I'll skip the other little video or whatever. But our last little fun thing I want to try, and this is what we're going to do with these. So you can see I gave you guys all a ball. So it's a little stress ball, but most of them all have a little world on it, right? This is to represent what the world looks like. So tell me, is the world flat or is it round? It's flat, isn't it? Yes, it is. Oh, it is too. Did you know there's two ways to map the world? One way is locally, so really small, kind of in a micro sense. And when you map things in a micro sense, it is flat. Can you see the curvature of the Earth? You can't see it, can you? Now I asked you, is it round? Is the Earth round? How do you know? Just because of this? Because of the ball I gave you? No, this is Hollywood. This is Hollywood. This is all it is. All right, so it's actually, we're not round either, but we are a sphere. We're spherical, but we're not a perfect sphere either. Did you know when the Earth spins, did you know at the poles that it starts to compress? So the Earth is spinning so fast that it starts to compress at the poles and it bulges at the equator. We will not die. We will absolutely not die. We're still pretty solid here, so nothing to worry about. But that's really what the true shape of the Earth is. Okay? So, but with that, there's a part of what we call measurement. When we start measuring things, there has something to do with what we call precision and accuracy. And we're going to do a little test. We're going to have a test to see how precise you guys are and how accurate you really are. So first is understanding what the difference is between the two. So precision is how well you can repeat something. So if you're throwing the ball back and forth to one another, how many times can you hit the target? In the exact same spot. That's precision. But now on a target like this, you want to be not only precise, but you also want to be accurate. So that's one of the biggest things that I teach about is accuracy and precision and the difference. And hopefully you guys will begin to understand that. In the past, when we used to measure stuff, we'd always say, oh, if it's within a foot or two, we're fine. It's okay. But now, the way it is and the way design today is, if it's within less than a millimeter, now we're okay. Tolerances have really gotten a lot smaller. So to understand this is what I use the balls for. So that every one of you guys can have a little bit more of a visual understanding of precision and accuracy, as opposed to just me talking about it. So we're going to have a test. So I'm going to stand over here against the wall, and you guys are going to stand all over here in the middle. Okay, then we're going to have a test to see how accurate or how precise you guys really are. And you guys get to throw the ball at me. So, everybody, I want everybody to get on over here. You can't just sit down. Don't throw it yet. No throwing yet. Oh, you know, this is awesome. Okay, so look here now. Everybody over here? All right, so for those of you that are in the front, you guys have to get on your knees. So that way, the people in the back, when they throw it, they don't hit you guys in the back of the head. I didn't make them sign a waiver. All right. I think have you be quiet for just 1 second again, okay? Not yet. Not yet. Okay. So look at my target, everybody. You see the target? Where do you actually want to throw it? My face. Is that what you're saying? You guys are a bunch of mean kids. What did I do to you? What? Okay. All right, in a real sense, if this was $1 million on the line right here, and I said right there is the $1 million mark. Where do you want to hit it? Oh, it's still safe on my face. That's awful. Okay. All right, so what we're going to try, we'll see how it works. Now when you throw it, I'm going to have you guys all throw it at the same time. I'm not going to move. I promise. Okay, I promise you, I won't move. I might close my eyes, but I won't move. So after it's all thrown, I want you to tell me that. So here is the real goal. The real goal is actually the target. Now I know you're going to hit other places. But that's okay. All right, so is everybody ready? Now wait, no, I get a count, not you guys. I get it. No, not yet. Parents, you guys want to do this too? Does you want to throw it? Oh, look at her, she's like, yeah. You want to put it up there? Oh, really? Yeah. Oh, I'm going for it anyway. Oh, no, that's okay. All right, look at that. It's almost at the same height. So there's the target. Okay? So are you guys ready? No. You can't get that close. Yeah, I gotta. Okay. Now this is how it works, okay? I'll say 3, 2, 1, throw. No, not yet. I wasn't ready yet, okay? So when I say throw, that's when you're gonna go for it, okay? Now remember, you see this beautiful face? This. Hey, this is the moneymaker, okay? So you gotta be real careful and then you go for it, alright? So everybody up closer, you guys gotta scoot back just a little bit. Okay, ready? 3, 2, 1, throw! No, not too close. All right, that's it. Good job. Okay. All right, I want to ask you guys now, how many times did I actually get hit? I think I only got hit like 5 times. So does that tell you, no more. So does that tell you, now look at the screen up there. Okay, so the idea for you guys, this is the beginning. This is the beginning when you start to think about precision and accuracy and technology. You got to use it. Use your heads when you get into it. And I hope that you guys have a phenomenal career, phenomenal life within the STEM field and whatever else that you guys are doing. And I hope you guys enjoy it. So, I think it's lunchtime or it's question time.
All right, we're going to have a quick Q&A. Raise your hand. Anybody have a question for Rockstar? Yeah, stand up and question. You have a question? No, like. Who have a question for Rockstar? Anybody? Anybody have a question? Yeah, this way.
No, you only have the one shot.
Anyone else have a question? Yeah, there's a question over here. Is your grease okay?
Absolutely. There's no bruising. See, I'm still going to be ripped. It's all right.
Yes. Do you play Fortnite?
I don't, but my kids do. But let me tell you one thing though. You talk about video games, you know, like playing that kind of stuff where all the design comes from. You've seen downstairs and gone through there, all the coding, all the design. It's all 3D, right? And it all comes back down to the basic principles that you guys have just seen right here, photogrammetry and geomatics.
Any other questions?
How much money do I make? I make enough to take care of my family. How's that? My kids can drive Lamborghinis and Ferraris, so yeah. What's that? For the imagery? Yeah, there's a lot of different applications for imagery. So you guys understand, like, whenever we try and map things, you guys saw the Google Earth display downstairs? You guys ever wonder where that comes from? That comes from imagery. It comes from the satellites, but the imagery on the satellites. And then we stitch all those together, so now you guys have this more realistic concept of what the rest of the world actually looks like.